1/4. Just wait a minute. Just wait for few minutes. One sketch I have to write, because 3-dimensional sketch I cannot write. I got a photo here. Seeing the photo only I can write. Actually, where shall I write it? I'll write here. 1 minute. This is a problem of not having architectural background. Okay, that much not required. It less 1 minute. Again. Okay, I'll put the sketch here first. Little cleaning required. Okay, no problem. Writing is not a problem. To make the question fully complete, so that no doubt comes for column design, I require the sketch. This way column, out of scale. This is a little longer. Okay, that is not a problem. It's longer. One beam comes here. See correctly. I will not explain again. One beam will come here. It will come this way. Cut. This you cannot see. Okay, then one beam goes here. This side also beam goes. I am not bothered. One side sufficient for me. One beam goes this way. It has got a depth. Maybe little higher depth. Okay, little higher depth. That is not a problem. This beam goes this way here. No, it may be that beam is a little smaller size. Okay, this way. That is not correctly fit into that one. Cut here. As I come down here, these are all you have to imagine. Then here, around the 400 side I want, 300 side. Okay. One beam here, this way, and then this way. Okay. And here, little longer line. Little longer, beam goes here, not from there. Okay. This way, then this way, and this way. Okay, no problem. See now. This unsupported length, I'll write here. I'll write unsupported length, L0. I'll make it visible. Okay. I'll make it visible now. L0 is 5 meter and L effective is 5 into 0.8, 4 meter. Why means don't ask questions. Here, along this face, this unsupported length, here L0 is around 4 meter and L effective is, this is actually not 5 meter, I'll make it 6 meter. 6 meter, L effective is 4.8 meter. Here, L0 is 4.2 meter, L effective is 3.300 means, no, L effective, not 6 meter, 5 meter, L effective is 4 meter. Okay, done. Column side, this is 300 mm, this is 600 mm. It's a column side. Okay, now 1 minute. Sufficient. I will make the screen clear now. If not visible, make the screens clear. I'll come to chat box because I'm in the WhatsApp group there. YouTube. 1 minute. basic tech, it should be ETAPS and safe. Okay, I'll make it visible now. I'll rotate so that it is visible. 1 minute now. Okay, 1 minute here. Now, little upper side. If I take little upper side, okay. 1 minute. Now I won't change. I have to go to higher, this one. Even I can't see anything because advanced 480. You should go to 480 to have a clear view. Okay, L0 6 meter, 4.5 5 meter, 4 meter. That now fully visible. Little visibility problem is there, I think. 1 minute. Because when I go in front of camera, it will be okay. Autofocus required. 1 minute. Okay, I think now. Okay. Now, everything visible? Just tell me. Everything visible now? Voice also clear? No. Now, everything visible? Voice also clear? Okay. Start. Now, write a note. We are going for design of column section, final part of the column. This is a conclusion. Means practically I told today's class most important. See, we are going for design of column section, design of column section or design of column sufficient, subjected to axial load with biaxial bending. I told you biaxial bending. This is a very important. Axial load means what? PU. Biaxial bending means two factored BMs. One of them is MU1, other is MU2. You write there. I cannot keep on writing everything now. You write all the notes. See, today's class, you require Excel sheet. I will tell you in the end. The one who is preparing Excel sheet, I tried to contact him, could not contact him. I will tell him afterwards. So tomorrow, the Excel sheet part, I will send in the RCC and ETAP group for you to, that Excel sheet I will explain here. Once he prepares, I will send it to you in the group. Okay, now, I told you one already ready-made problem is there, but I could not get the problem, I am searching. No problem. I will create a new problem so that everything you are knowing. See, PU is the factored axial load. You should write. PU is a factored axial load. Then, one of the factored BM is MU1, other factored BM is MU2. Two axes you are writing in the cross section, 1, 1 and 2, 2. Factored, you should write everything. I am not writing here. Factored BM, see, this is factored BM about 1, 1. Axis 1, 1. I will show it later. This is factored BM about axis 2, 2. That means, see, I write here. I will show some more square section so that you can't make out which is bigger, which is smaller. See, this is the cross section. This is the front side of the column. What you are seeing axis here, in my class, I call this as 1, 1. See, this is 1, 1. How you write this way, this axis, I am calling 2, 2. Whereas IS code told, one of them is XX, other is YY, but conditional. Sometimes this will become XX, this will become YY. If XX is, if that 1, 1 is major. Suppose, see, as per code, if the column section is like this, then this is XX, this is YY. Whereas if the column section is like this, then as per IS code, this is your XX, this is YY. Because they told with respect to major and minor axis. Major and minor axis. So I will first make it clear what is major and minor axis. See, now suppose I take a section here. See, this side I will take S1, permanent in my class. See, in our class, no confusion, S2. When you go to Excel sheet also, do same way. And one more thing, remember, actually Excel sheet is required only for those who are going to do manual design of the column. See, actually column design, you don't have to do anything. Prepare the model in E-tabs. That is our course. Apply the load, create load combination, analyze and design. Over. E-tabs will tell you the steel required. Over. All the repeated trial and error, interaction diagrams, or that combined action of this one, everything, E-tabs will take care. You don't have to worry. See, design. Over. That's all. Click the design without even bothering what is the axial load, etc. In the building, how much load comes, how much BM will come, considering the frame action, considering the earthquake, considering what? Wind load effect, and also if it is a long column, then extra BM, additional BM, and also BM due to E minimum. Everything will, E-tabs will take care. If you right click, you can see all details there. Otherwise, once you get full confidence in E-tab, nothing. But sometimes it is possible that you may be asked to do manual design. See, some critical column is there. People sometimes gets upset. They tell E-tab result, I don't think satisfactory. They will tell you, okay, do manual design. Then you have to tell, I don't know. I know only E-tab. Then he will tell, you are doing a clerical job, not structural designer job. So design column principle should be known. And at that time, if you got, see, not once, it may happen many times that you require column design manually. Then the Excel sheet I am telling you to prepare is very helpful. So in the end of the class, once I finish, see, this today's class question, trial and error is there. But you don't have to bother. E-tab will do it. But manually, there is trial and error. So after the first trial, as soon as the first trial is over, immediately what we will do is, we will prepare Excel sheet. Tomorrow's class, someone should prepare Excel sheet and bring it. And second trial means repetition. Maybe repetition, one round I can do. Then I will tell, now use Excel and tell the answer. Those who are interested, they don't use Excel. Every time they can do manual design if you are interested in learning. So now see, what our principle is, see, this is our one BM, this is other BM. I told you, see, this is the BM about this axis. So this is our MU2. This is the BM about this axis. This all I will not tell now. MU1. A factor load is here, PU. This is our principle. This I told repeatedly earlier. Now, IS code told not that way. Sometimes they will tell this is XX, sometimes this XX. What they told is, and sometimes they will tell BD square, sometimes they will tell DB square. No, I don't prefer that is correct. IS code should have come through a other way. What I am telling, if they tell that way, it would have been more sense for people. Anyway, IS code published, but I am not deviating from IS code. The pattern they maintained, same we are doing. But confusion avoided in my class by taking no major minor. See, now, just for your information, what is major, what is minor. You know that when bending comes, strength is more if what more? Strength become rapidly more if depth is more or breadth is more. Tell the answer. Strength rapidly more if depth is more or width is more. Say again, I told you, this group, as I told earlier, remember, people are so lazy, they want ready-made food. Therefore, after finishing the column part, foundation part, I am not coming public. I will send. The moment column is over, I am stopping the live stream in YouTube I am going to my original Zoom only. I told very clearly yesterday, this response is not good. See, when someone, suppose a public speech given, recording is done, later it will come in the YouTube. People will tell, why go there? We will watch YouTube. Correct. But some live audience required. I should know how many are watching, what response comes. Nobody there. Everybody want to go and see later. So therefore, pay penalty. If you really feel my class is very useful, you should regret. That's all I want. You should regret. I should have come at least, I should have come live and see that we are interested. If you don't show the interest, I am helpless. This is not binding on my part. My course class is there continuing. So as soon as the columns are over, then the most critical part, foundation, I am leaving, I am continuing in the original format. That is, people who are in that group, for them I will continue. That's all. But column portion, I will completely finish now. Whatever is there. Column, completely finishing. Okay. See, even I saw there earlier, some people there suddenly vanished. Suddenly vanished. Okay, enjoy. If you are so much lazy and not showing interest, just, oh, he is doing something, we will use it. Let him do, useful. At least to show that, yes, we are using it, let him know. If that much seriousness is not there, I am helpless. No problem. Okay, now, when depth is more, see, if very people are there, opinion comes only from few people. If series of people are there, comment box, you can see plenty of answer. When series of answer comes, little motivation comes. When I ask a question, when it is clear, I will ask you breadth or depth. If non-stop you get depth like that. Yes, I feel, yes, people are knowing. Same person, he told, see, only one person is chatting, that's all. Others all silent. Okay, leave it. Tomorrow, if a little portion of column remains, tomorrow I will start, tomorrow class at 5 o'clock, I will start, and then the moment column over, I will stop the live stream, and other group, I will send the link for Zoom and continue foundation there. That's all. Okay. I won't tell once again now. So it is depth more. See, when I first started recording for online class for YouTube, nobody used to be there in front of me. I used to get a very odd feeling. Because when nobody is there, recorded, see, that except BMD course, record version, when I started here, very odd feeling. Nobody is listening, whom I am talking, like that. But slowly that went, because now I know people are watching. So that feeling comes. Here, when the option for live is there, if you are not using, you should regret later that important portion, you have missed it. Okay, start, continue. Now, when depth is more, then section is stronger. Therefore, remember, here, with respect to x-axis, this is the depth. See, I will tell you here now. See, for this cross section, for if I take this way S1, this way S2, then S2 is more than S1. See, with respect to x, your S2 will become depth and S1 will become breadth with respect to x. And same way, if I, same cross section, see, if I put y, this is for x axis, see. Now, y axis is here. For y axis, I told you, side parallel to axis is always breadth. This is S2, S1 only, no change. Now, for y, S1 become depth and S2 become breadth. Therefore, tell me now, is this column section stronger about XX or YY? Answer. Only one will give the answer. Okay. Is this column section stronger about XX or YY? Fast. Is this column section stronger about XX or YY? Which axis? This section is stronger about XX or YY? YY. Ah, what is this? What is this? All this explanation told, finally you tell YY, I should stop the class. With respect to xx, depth is s2. With respect to yy, depth is s1. After explaining all this, if you blindly tell which one you told? Yy, what I can tell? See, this is first of all strength of materials. With respect to x axis, this is the depth. So it is difficult to bend like this. It is difficult to bend like this. Actually, it is easy to bend like this. Therefore, where resistance is more, or where depth more, or in strength of materials, remember, I about this axis is S1 into S2 cube by 12. I about this axis is S2 into S1 cube by 12. Which axis has higher moment of inertia? That is called major, which is minor. So here XX becomes major and YY becomes minor. Now same column, if I place this way, see this way, then still if I write this is XX and this is YY, not IS code, then here your YY will become major, XX will become minor. But IS code told not that way. Whatever way you place, which is major, you call XX, which is minor, you call YY. So confusion. So what I am doing is, I am avoiding that trouble by giving the name MU1, MU2. No confusion now. See, one concept, MU1, MU2. So this is the best one. Okay, now, see, right time some problem. I think I should bring some water today. Don't know. Okay, when I start the column design, I will clean the board again. Little ink problem. Sometimes the ink give trouble. It will not go so easily. Okay, leave it. Little later I will clean it. See, these things all, I am not bothered. This is called style. Though people don't want these things all. Okay. Now, further. This column, see now, the question today is, the question for today's class is a column cross section, a column of cross section 300 millimeter by 600 millimeter. 1 minute now. I will tell you one more thing. Why I took 300? Even though most popular lesser side is 200. There's a reason. If I take 200 millimeter, then for the d dash by d value in SP16, interaction diagram is not there, because if I take by chance 200, then if you take 25 mm diameter bar, then 40 plus 12.5 is effective cover, divided by 200, it gives you 0.2625. Means your d dash by d is above 0.2, above 0.25. Okay, 0.2625. Okay, 0.25 you can make, but 0.2 is not correct. Therefore, in SP16 interaction diagram, it is not there. E-tab is not bothered because E-tab is not using SP16. E-tab is using the equation. So for E-tab, there is no problem. E-tab, there is no problem. Why? It uses equation. But practically what to do? Practically what to do is, if you see, actually long back, when I started the course around 10 years earlier, the professional classes, one of the first professional training batch, I told them, I derived for them interaction diagrams. How interaction diagrams are prepared, what is the principle, etc. Everything. It started raining today, I don't know what is the problem. Suddenly rain. If it very heavy rains, you can't continue the class. That one problem here. Very heavy rain. I think right time, critical class, some disturbance. Maybe rain also want to give trouble to you. Okay, I'll continue. Because I can't pause. There is one problem in YouTube. You can't pause there. If I stop for some time, it will be blank. That's all. Okay, I will close the door for sound problem. Right time, rain problem. Okay. Anyway, hope voice is clear. Okay. Now, see, Therefore, sometimes people ask, sir, if 200 is there, what to do? You can't use SP16. In that batch, first batch, I told the principle of what? Interaction diagrams. I proved it. One or two students, they prepared interaction diagrams for d dash by d 0.25 also. They prepared for 0.25 and 0.3 also. Later I checked it, perfectly correct. That much serious students. See, they prepared interaction diagram by the equation or principle told by me. And one textbook, I don't know, he has prepared interaction diagram for even 0.25 also. You can use that one. But anyway, remember, these are all you require if you are manually doing the design. Our course is E-tab and save. Therefore, for designing by E-tab and save, you don't require these things. But safer side, then what you can do is, suppose imagine you get 0.25. 0.25 graph is not there. Use 0.2, but provide little liberal steel, little exaggerate. See, as d dash by d increases, it is bad. See, higher d dash by d is actually bad. Bad means what? Not good. Therefore, if you get 0.25, you can use 0.2, but when provide steel, little liberal. That all you will learn later. Okay, start now. A column of cross section 300 by 600 mm is subjected to factored axial load of, I should set the question, 1 minute. I will use M25 and FE500. I am directly giving you factored load. If working load given, you have to factor it. I told you repeatedly that one. Axial load of 1800, say 1200 kilonewton. Okay. This is the actual load. Then, further, unsupported lengths and corresponding effective lengths are 6 meter, 4.8 meter and 5 meter, 4 meter along the face of 600 mm and 300 mm respectively. Means along the face of 600, unsupported is 6 meter, effective 4.8. Along the face of 300, unsupported 5 meter, effective 4 meter. See, I have drawn the sketch here. See there. Along 600, unsupported 6 meter, effective 4.8. Along the 300 face, unsupported length 5 meter, effective 4 meter. Over. Now, column cross section is subjected to factored BM of, I'll give BM value, for example, some 50 kilonewton meter, 50 okay? Okay, 50 better, I'll let more. 100 kilonewton meter, if it goes dangerous, I'll change later. 100 kilonewton meter and 70 kilonewton meter about major and minor axis respectively, right? This may be due to frame action or earthquake or wind load, etc. You write These are due to the frame BM, or you get the BM by analysis. Axial load of how much? 1200. Then about the major axis 100 kN meter, about the minor axis 70 kN meter. This is the data given. Okay, now design column reinforcement. Design column reinforcement taking M25 concrete and FE 500 steel. M25 concrete and FE 500 steel. I am getting very irritated by the rain. You don't know how much angry I am. Right time rain problem. Here upper side sheets are there. So if rain comes, little sound comes. Hope at least for some time it will stop. Okay. Unseasonal rain. Nobody expects rain at this time. Okay. This is the question. See. Correctly write one by one data now to make perfect design. See. Now, this all I told you. Now see. Now, no S1, S2, nothing now. Or in general you take yes, little later. See, these all I am removing now. You write what data is given. Notice. Given data is, I will clean this once again. That solution now. Solution. First put the sketch. Then given data. PU. Factored load given. PU. 1200 kilonewton. Okay. Then factored BMs. Factored BMs right here due to frame action or earthquake or wind load, we don't know. This is the actual BM given by analysis, or I will take the cross section like this. See, as per my sketch, see here, front side 300, this way 6, anything you can take. I will take 300 here and 600 here. Now, see correctly. This is 1 axis. 1 minute. I'll put somewhere here. This is your 600. This is your 300. Now, this I will call 1. This I will call 2. PU is here. Tell me, what is the BM as per their statement? This is your MU2. And this is your BM MU1. Tell the answer. They told about major 100, about minor 70. Therefore, tell me, among this MU1 and MU2, which is 100? Or one of them is 100, other is 70. Now, tell correctly whether you should tell MU1 first, then MU2. Is MU1 100 or MU2 70, or is MU1 70, MU2 100? Tell the answer. First option, MU1 100, MU2 70. Second option, MU1 70, MU2 100. Tell correctly which is correct. Which is correct? MU2. Ayyo, what is this? You are all telling completely meaningless answer. How possible? See, about the major axis. Tell me, which is the major here? See, this is 300, this is 6. That is called randomly giving answer. All my explanation wasted. I should stop the class right now. Why? If such things happen, sometimes become irritating. After explaining so much, if still answer is meaningless, because only 1 or 2 are giving answer. That's why I am stopping this class, live streaming. Foundation for everybody gone. It is only for the selected group earlier. That is usual group. That's all. Tomorrow onwards link will not come for you. I am become very firm now. No, stop. You don't deserve it. See, now, which is about 1. See here. This BM, tell me, this BM is about which axis? Tell me answer. This BM is about which axis? 1 or 2? 1000 times told. This BM is about 1. Actually. Here which is major? 1 major or 2 major as per the sketch. Which is major here? Which is the major axis? 1 or 2. Axis for which depth is more? 1 major. So therefore remember, this is what? MU1 is 100, MU2 70. Okay, now that's all. Further I can't explain because this is not strength of material class. Someone will tell, sir, not clear. Learn strength of materials. Learn bending stress chapter. There lot of information is there. When you or direct bending and compression, there you learn axis problem comes there. First of all, here I am wasting time by explaining this axis problem here in this rain. When rain is irritating, first of all I am wasting time. Okay, but still I am telling. Okay, over. Now, therefore, I will tell you one thing now. I will make a, see, this I will remove. I will make a small chart now. A small chart. See, remember, your PU is 1200 kilonewton. Okay, leave it. Over. Now, about the axis 1, I will write here. About the axis 1 and also about the axis 2. I want what is MU means this is MU1, this is MU2, MU1, MU2, MU that is given BM. Right here, given BM means the BM due to frame action or earthquake or what? Either due to frame action or earthquake or anything. About 1 it is 100 kilonewton meter and this is 70 kilonewton meter. I don't know, right? In the right day, this ink trouble. See, other days no problem. Today only ink trouble. It has never happened earlier for a long time. When problem comes, it always comes in series. Okay, now, do one thing. Leave it. Tell the table. Wait for some time. I will come back to you later. Later I am coming back. Now I want MU due to E minimum. Due to E minimum. Now I want MU due to E minimum. Means once again MU1 and MU2 corresponding to E minimum. See, start. First, consider L0 equal to anyone first. Okay, take this one first. L0 equal to 6 meter and L effective equal to later. See, I also want one more. Later I want again MU additional if slender. If slender, I want one more later additional MU if it is slender. Okay, start. Finish. Consider L0 6 meter and corresponding L effective 4.8 meter. One of them I will do it, other you have to do. 1 minute. Therefore, I will do one thing now. I will take L0 equal to 5 meter and L effective equal to 4 meter because reason is there. 4 meter. That is measured length along, the length is measured along 300 mm side. Therefore, structural depth equal to 300. I already told you. Structural depth, which side you consider. So, your S equal to 300 millimeter means that S is structural depth. Therefore, tell the axis first. Axis. When I tell depth equal to 300, tell the axis first. First axis. Which one? If it is not clear, let it be not clear. When I take structural depth equal to 300, which is the axis? First. Axis. Axis 2. Remember, axis is therefore 2. Therefore, what I am going to write? I am going to write here now. See. MU1, MU2. I am filling up here now. This you have to fill up. You have to fill up this one. When you take L naught equal to 6 meter and L effective equal to 4.8 meter. After I finish this one, leave it. Now start. First, E minimum. Formula you write. I have better works to do than every day telling the same thing again and again after explaining not once, not 2 times, 10, 15 times explaining. I have got a better works to do. Refer and tell the answer. Equal to L naught. How much L naught? 4,000. Some will tell, oh, what is this? This question, he is not giving formula, substituting. I will tell, leave the class. Don't come to my class. If you have no patience of studying the earlier class and what I told 10, 15 times, if you have no patience, then don't come to my class. That's all. 4,000 by 500 plus side of 300 by 30. Answer fast. You should do one thing. Later, you write the statement here. Answer. First. Today I decided not to use calculator. Answer. Exact 20. Exact 20, na? Exact 20. Ayo. Is it exactly 20? L naught is 5,000. Sorry. 5,000 by 500. Okay, sorry. 5,000 by 500 plus 300 by 30. Is it exact 20? Yes. Do one thing. Small correction to the question. I do not want exact 20. So take the length as not 5 meter. Take the length as 4.9 meter. In the question, change the question. You write that question you change. I told you one of them is 6 meter and 4.8 meter along the 600 side, and I told 5 and 4 change it to 4.9 and 4. Why? I do not want 20. Now tell the answer. Little change, correction, deliberately. There is a reason for it. Reason for it. Change the question. Answer. 19.8 millimeter. 19.8 millimeter, which is less than 20 mm. Therefore, tell the answer. E minimum equal to, tell me how much you have to take. E minimum, how much you have to take? It came less than 20. That's why I want it. How much you have to take? You have to take 20 mm. See the statement there. Sorry, not explaining. Over. Then, therefore, mu due to E minimum. Remember, don't compare with 0.05b. Comparing with 0.05b is not for today's problem. It is for short column subjected to only axial load. When bending moments are all there, that is all forgotten. Okay. Mu due to E minimum equal to Pu into E minimum. Pu is 1200. E minimum is 20 millimeter by 1000 meter. You get the answer in kilonewton meter. Tell the answer. 20 convert to milliliter. Answer. Bm due to E minimum. What is the Bm due to E minimum? How much? 24 kilonewton meter. Okay. 24 kilonewton. Therefore, see, I told you I am discussing two axes. Bm due to E minimum is 24 kilonewton meter. Okay, now also continue once again. And also L effective by S. L effective I told 4 meter. 4,000 by 300. Answer. 4,000 by 300. Answer. It is undoubtedly 13.33. Yes or no? I want column to be long. Is it correct? 4,000 by 300 is 13.333. Correct? 13.333, which is more than 12. Therefore, column is slender. Column is slender. Slender. Because the column is slender, now remember, I am going to remove this sketch. I want some statement here to be written. This sketch I am removing now. Remember later, 1 here, depth is 600, to here, depth is 300. I will explain once again. This sketch I am removing. Okay, not required for me. Okay, now, slender column. Therefore, continue. We have to consider additional BM, factored BM, that is MU additional equal to PU into S divided by 2000 into L effective by S whole square equal to 1200 by into S is 0.3. Why? I want meter. Divided by 2000 into L effective by S is 13.333 square. Tell the bending moment. Extra BM you have to consider. How much answer? Extra BM you have to consider. How much? Extra BM. What is the additional BM you have to consider? Only one person is giving answer. Others all sleeping. This is very bad. This is why I told I am going to stop this live streaming. You don't deserve it, first of all. You will regret later. One fine day you will regret. If I had continued foundation, lot of doubts I am having, very helpful for me. Regret. Okay, answer. Give me in kilonewton meter. I wrote in kilonewton meter. 1200 into 0.3 by 2000 into 13.83. Why Newton millimeter? How 32,000? This is in kilonewton. This is in meter. This is unitless. Why? It is L effective by S. How much? 32 kilonewton meter. Okay. It is 32 kilonewton meter. Remember, this is additional bending moment. Danger. Remember, this is additional bending moment. Additional. So the additional bending moment is 32 kilonewton meter, about 2. Okay, now I'll take a small break now. What you have to do is repeat the procedure. See, I write, consider L naught equal to how much? 6 meter and L effective equal to 4.8 meter. Tell me, then, fast tell me, then what is the side you are taking? If you take L naught equal to 6 meter and L effective 4 meter, which is the side to be considered? Repeatedly told earlier. Which is side to be considered? When you take length in along one side, what is the side to be considered for structural calculation? How much? Someone will ask, for this length he is taking that side, for that length he is taking this side. This person does not know subject. Yes, very good. Yes, that's what. You are genius. How much? You have take the side of 300. I took. Oh, it is completely gone. I think, see, we made a mistake here. I took wrong dimension. L naught 5 meter and L effective 4 meter means yes, how much? Oh, this is very bad. Very bad from your side. I did not observe there. This is very bad. Correction required now. See, this is very, very bad. After explaining this much, this is actually what happened is I did not see values there. When you take L naught equal to 4.9 meter and L effective 4 meter, tell me which is the side you have to take. What is this? After explaining so much, which is the side you have to take? If you do this way, what I can do? That shows you are not interested. I should stop the class. I explain not one. Someone will tell, oh, this person lost control. No, I did not observe there. I was only seeing numerical. I first wanted actually this one. By mistake, I took that one. See, I came to know now. When you take this length, you have to take what? You have to take side of which one? When you take this length, your side should be 300. When you take this length, your side should be what? should be 600. Therefore, this is very, very bad. See, I told you, very, very bad. What you have done is very, very bad. So, when you take L naught equal to 4.9 meter, L effective 4 meter, your side to be considered is how much? 600 millimeter. What is 600 millimeter? That means, which is your axis? Correction, see, if there is by chance a print mistake is there, I can make out immediately. I will not continue. That much, I am not that much weak. Once I looked there, I did not look there once again. For me, it is oversight or print mistake. For you, it is technical mistake. So once I take L naught equal to 4.9 meter, L effective 4 meter, side to be considered is 600 millimeter. What is this? So it is what? It is, how much L naught? 4900 by, how much it is? By 500 plus 600 by 30. What is the answer? 4900 by 500 plus 600 by 30. What is the answer? See, this is very bad. Sometime, for this reason, I will stop the class. I will tell them 100 times I told you earlier, repeatedly. Maybe oversight. See, the sketch is not, I did not see there. I took a wrong what? I took that one. Actually, when I came here, I thought I took the other dimension. That is print mistake from my side. If you are not that much alert, I will tell not fit for learning. How much? 29.8. Now you are telling. E minimum is, okay, 29.8 millimeter. That is more than 20 mm. So, E minimum to be considered is how much? 29.8 millimeter. And also, mu due to E minimum is 1200 into 29.8. What is the answer? Such mistake you should avoid. Actually, practically remember, eta will take care of all these things. How much answer? Answer 1200 into 29.8. 29.8 by 1000. By 1000. Answer 35.67. Okay. 35.67. And one more thing. Tell me axis now. When depth is 600, which is the axis? See, which is the axis you are considering? What is the axis? When depth is 600, which is the axis? 1, 1 or 2, 2? That, see, I took that, I saw the depth and decided axis now. Which is the axis? When depth is 600, which is the axis? 1, 1 or 2, 2? When depth is 600, which is the axis? No answer. Which is the axis means stopped. 1, 1. See, axis 1, 1. If I forgot this one, made a mistake, then I have to delete that one from YouTube. But 1 minute, I will tell. I only told so many times earlier. After all, when I saw the length here, when I went there, it got interchanged. I suddenly came to know by looking. I looked there and looked here. See, I got odd feeling. It's because my little structural knowledge I got. Therefore, remember, this is not this one. Mu1 is how much? Mu1 is 29.8 millimeter. Okay, 29.8 Newton kilonewton meter. Okay, okay. Then also L effective by B is what? 4000. Corresponding effective length is 4800 by 600. What is the answer? 4800 by 600. What is the answer? 4800 by 600. L effective by S. First of all, such mistake should not be there. Be careful. 4800 by 600. Sometimes it happens. So many times it happens. A problem I am solving, some other beam load, by mistake I will put here. Then some will tell, sir, wrong. Don't tell wrong. I will tell print mistake. 8. See, it came 8, which is less than 12. So column is short. Column is short. Therefore, write no additional BM. no additional BM. So for this one, mu1, additional BM is no, dash. Why dash? Not there. Not there. Okay, now repeat. Now take L0 equal to how much? 6 meter. L0 equal to 6 meter. And L effective equal to 4.8 meter. Tell fast. What is the side you have to take? Fast tell me. That is measurement along what? Measurement along 600 mm side. Therefore, side to be considered. Yes. Which is the structural D. Which one? Side to be considered and structural D. Which one no? When I take L0 equal to 6 meter and L effective equal to 4.8 meter, then structural depth to be considered. How much? 300. When structural depth is 300, tell the answer. Then at that time, depth is 300. What is the axis to be considered? Now you will tell the answer. Why? One axis over other axis. When structural depth is 300, which is the axis? Axis. Axis is 2, 2. 2, 2. Therefore, now I want this value and this value. Okay, now remember now, here L effective by S. Repeat. This time it will not come small, it will come slender. Slender. And we have to consider additional BM. See, this time when you calculate L effective by S, it is how much? It is, where is the L effective? 4800 by 300 is 16, more than 12. Column is slender. Column is slender. So, therefore, additional BM is there. Additional BM is there. Is there. Therefore, continue. Find the additional BM. Now you do one thing. I'll take a small break. You tell me this value and also tell me this value. I'll give 5 minutes time for you. You take L0 equal to 6 meter, L effective equal to 4.8 meter, structural depth equal to 300, axis is 2 to find E minimum, compare with 20 mm, take the higher value, then find mu due to E minimum, and also column will come long or slender, find the additional BM in the same way, number will change. Okay, start. I'll give 5 minutes break. I'll give 5 minutes break. For me also let the break required. After 5 minutes, I'll continue. 5-6 minutes. You calculate both, then you are ready for design. Have your IS code and SP16 ready with you. IS code SP16 ready with you. Okay, ready, you start now. I want you to calculate, because if I ask you to calculate, you may take 1 hour, 1 day or 2 days for that one. Where is my calculator? Here. See, next, consider E minimum equal to unsupported length is 6 meter, 6000 by 500 plus side is 600 by 30. Which one you are doing? No. 6. Unsupported length how much? Unsupported length is 6 meter, 6000 by 500 plus side is 300. 300 by 30. It will come 6000 by 500 plus 10. It will come 22 millimeter, more than 20 mm. Therefore, E minimum to be considered is how much? 22 mm. Correct answer? Answer correct? Oh. E minimum is 22 mm. Correct? E 22 correct. Fast. 22 millimeter. Therefore, mu due to E minimum equal to 1200 into 22 by 1000. How much answer? 1200 into 22 by 1000. 1200 into 22 by 1000 is 26.4 millimeter, kilometer millimeter. Okay. And additional BM is 1200 into 0.3 by 2000 into how much ratio? 16 square. 16 square. That will come 1200 into 0.3 divided by 2000 into 16 square will come 46.08. 46.08 kilometer meter. So here how much? This additional BM is here what? Here I am writing. The additional E minimum BM is 26.4 and this is 46.08 over. Now full ready. Correct answer? 46.08, 26.4. Okay, now come to the last part, closing part. See, therefore, all I am removing now. Therefore, now see, IS code told something. You need not consider both the E minimum simultaneously. When you do that one, this can be ignored. But that nobody is going to do it. They will tell ignore it. They will consider both simultaneously because safer side. So they told you can ignore it. When you consider E minimum for with respect to one side for the design, at that time other one you need not. They told need not consider. So we are not we are considering it. Therefore, the final design values are PU equal to 1200 kilonewton and MU1 is, see now, there is a BM of 100 and MU due to E minimum 29.8. What do you have to do? Among these two, tell me, consider which one. See, final BM is always equal to either BM due to either dead load, live load or earthquake load or whatever from frame you get or due to E minimum. Among those two, whichever is what? Among those two, whichever is, which one? Final to be considered is whichever is what? Among the whichever is higher, consider the higher. So it is what? 1200 MU1 equal to 100 or what? 29.8, whichever is higher than plus additional BM, but additional BM is 0. Therefore, take 100. Tell the answer. What is final MU1? It is not there. If it is there, you have to add it. That you got to compare. Among these two, whichever higher and plus that one, if it is applicable. Suppose it is applicable, add that one. Answer. How much? That is 100 kilonewton meter. And final MU2 is what? final mu2 is 70 or 26.4. Among these two, whichever higher, then plus 46.08. Therefore, tell the answer. Final mu2. Answer. How much? Either 70 or 26.4, whichever higher, plus 46.08. 116.08. It is 116.08 kilonewton meter over. Therefore, finally, our make a note now. I am dictating now. Our column section, 1 minute now. I want the answer now. I will write somewhere here. I will forget it here. How much it is? 100 and 116.08. Okay, done. I noted both of them. So, now remember, actually, all these are principles. First of all, I need not tell for E-tab batch. I need not tell for general public, but I should tell only for RCC batch. RCC batch, I already told there. Still, to give information, I did all these things. So finally, what you want will start now. I will clean the full board now. See, full board. Little problem is there. It will take little time now. See, I will finally write answer. I'll dictate now. You write. We have to design a column section 300 by 600, which is subjected to a factored axial load of 2200 kilonewton and biaxial bending. The two factored BMs are how much? 100 and 116.08 kilonewton meter with the M25 concrete and FE500 grey steel. By chance, if it is unsafe, if the column becomes unsafe, you have to, if you cannot design, you have to go for redesign. And in our class, what we will do is, if redesign comes, I will change to M30 or M35. Why? Practically, what you can do? Maybe one of the sides you have to increase and then make it safe. That I will tell you in the end of the class. Our purpose is to learn the design. Okay. Full I am removing now. So that number I am maintaining because why? I want it. Rubbing the board, actually, paper is the best. That other duster, it won't go cleanly. Okay. These things are all not a problem. See, somebody who wants stylish class, he will never do these things. He will either hide the camera and do all these things, or he will pause it. I don't give importance to such things like what those things like should not that rain coming. He won't tell that rain coming all. Okay, see now the final design is, see now correctly, the last ultimate part, our column cross section. Our column cross section is here. I will write, you can write whatever way you want. See, you can write either like this or like this also. No problem. One of the side is 300. 300, all in millimeter. Why waste time? Millimeter. Other side is 600. Hope board is, don't write S1, S2 now. One axis here, that is 1, 1. Other axis here, that is 2, 2. This is what we want finally. This is 1, 1. And a factored BM, PU is acting here. PU here. A factored BM, MU1. See, PU equal to 1200 kilonewton. Do one thing, into 10 to the power 3 Newton. Why? When you go for final design, we want in Newton millimeter. Remember, you write everything we have to consider in newtons and millimeter. Why? Design part, no kilonewton. 10 to the power 6 will be there. Board visible? 1 minute now. Board visible fully? No, is the board fully visible? You are not answering. What all I wrote, fully visible there? Later you should not tell this is not visible, that is not visible, like that. Yes, okay. And further see, there is mu1 of, how much I told? This is mu1. How much answer mu1? This bm of, it is not 100 I think. How much it is? mu1 how much? This is not mu1, sorry. See, this is mu2. mu2 of 116.08 into 10 to the power 6 Newton millimeter, and this way bm mu1 of 100 into 10 to the power 6 Newton millimeter. This is the final design, or you can write here M25 concrete. Therefore, your FCK is 25 Newton per mm square, and FE 500 steel means your Fy equal to 500 Newton per mm square. And also let us take 25 tor for longitudinal reinforcement. Therefore D dash. Now I am not telling what is D dash. If it is not clear, leave it, don't come to my class. Effective cover equal to 40 clear cover plus 25 by 2 equal to 52.5 millimeter. This is the and column subjected to what? You write here. We are discussing column compression subjected to compression with bending, biaxial bending, and FE 500 steel, and we are going for reinforcement equally on four sides. Therefore, chart number, tell fast. Chart number to be used is fast. Chart number. Last time I told you. FE 500 steel, biaxial bending, and column what? Reinforcement equally on four sides. Chart number fast. This I will not repeat. Chart number fast. 4 charts are there based on D dash by D. Depending on which D dash by D you will take it. Starting chart number. Tell the answer. Yesterday, last class I told you chart number. Anybody who is absent last time, don't come to the class. I am always like that only. Absent last time, not gone through. I am not the person for you. You will learn from high level people only. Understand everything, whatever I tell, thoroughly practice, then only you can learn from me. Chart number, fast. Chart number. This is actually, remember, our class actually starts from here. Which one? Actually, for general public, my class should start from here, and also for ETAB and Safe batch, class should start from here, but not for RCC batch. RCC batch, I tell so many things there. I even told interaction diagrams, what is the reason. Derivation is not done, but I told them the reason, how the curve comes that way, what way it varies, and when what will happen to reinforcement, how strains are coming, I all told it. So chart number 47 or 48 or 49 or 50 based on D dash by D equal to 0.05, 0.10, 0.15 or 0.20. Is this fully clear? Tell me. This is where, actually remember, my purpose of making this YouTube, this class, general public is this one. That's all. Not arriving at these things. General public, why it is, that you should remember at least one thing. Everything I told so far is a bonus for you. So you should remember, my commitment for general public is how to design a column section, how to design reinforcement when a column section is subjected to axial load with biaxial bending. Axial load 1200 kilonewton, factored BMs are here, axis 1122. I need not tell what is the axis, what is E minimum, long, short, all that comes in detailed theory. This is the most important. This is where so many got difficulty. So far, fully clear? Tell me answer. Is so far everything clear means I will start now. If everything clear, I will start now. Now onwards, correctly concentrate. Clear? Okay, start. Now, write a statement. See, design, you should write. Actually, first of all, I need not tell this one. Sometimes people will tell, those who are here, you are telling, need not tell. Why you are telling? Teacher's instinct, what to do. At least if some person interested, let him know. That comes from what? The teaching instinct only. When you design a column with axial load and uniaxial bending, you find PU by FCK BD, MU by FCK BD square, and there is no MU1, MU2, only one MU. Directly get P by FCK, accordingly decide percentage of reinforcement and compare with the minimum. You should not give less than 0.8 and it should not give more than 6%, and provide the reinforcement is for uniaxial. But when the column is subjected to biaxial bending, IS code only told it is a very lengthy procedure. It involves trial and error procedure by various neutral axis position, and so many things are there. Somebody just sent me a message that can you teach how to prepare the interaction diagram chart? No, actually remember, if I remember correctly, you came to that class, first the professional training class. In your class, nearly 15 classes I have taken for preparation of this interaction diagram. Remember, I don't mention names all. 3 or 4 among them, they prepared the interaction diagram at that time. I won't tell the names. 3, 4 people, they prepared the interaction diagram. You came there, I remember. You came there for the first batch. At that time it was Start Pro, not ETABS. So here I can't tell that one. If I tell that way, no one will come for ETAB class. He will tell he is doing only story. Okay, start. Now, how to design? It involves trial and error procedure. So what you have to do is, you have to first you have to assume suitable reinforcement. See, suitable reinforcement, percentage of reinforcement. That is P percentage. Remember, the percentage of reinforcement equal to 100 into area of steel, divided by gross area. Gross area is S1 into S2. Or some people tell either B into D or D into B, whatever you want. You have to first assume percentage of reinforcement, and once you assume percentage, and then check whether safe or not. Then if safe, you have to also check if it is too much over safe and uneconomical. If it is unsafe, you have to redesign. Okay, now how to check for safety is, see, check for safety right here. When a column section is subjected to axial load PU and biaxial bending MU1 and MU2, my symbol, IS code symbol is MUX and MUY. No, that is confusing. My symbol MU1, MU2, the check for safety is MU1 by, I will put MU dash 1, dash beda, I think somewhere, I will do one thing some other way. MU1 by, I will put MU not 1. I prefer not is better. Not 1 to the power alpha n plus MU2 by MU not 2 to the power alpha n should not exceed, anybody can tell? Should not exceed, anybody can tell? See IS code, I will tell you page number. See the IS code, I will tell you page number, but there you can see some other symbol. I make the symbol as per my convenience. Anybody can tell me answer? Should not exceed, how much? That ratio should not exceed 1. Okay, should not exceed 1. Now, one common sense, see now, IS code page number is 30, class number 39.6, page number 71. Now I will do one thing now. I will not use IS code. I will write my own language. Okay, start. It is here. Now, see the numerator and denominator. You should remember one thing. Here, mu1 and mu2 are factored BMs. See, factored BMs to which cross section is subjected to. While do slowly subjected to, or you can write this as action. You remember action or hitting, or remember you can somehow to understand. See that alpha n is there. It is not fully correct, but logically I am telling. It is like your bill. You go to hotel and eat something, that is the bill. Now tell the answer. Your mu1 is known for you, mu2 is known. Here see, mu1 is 110 to the power 6, mu2 is 116.08 10 to the power 6. They are action, or like somebody hitting you, or hotel, eat, bill, yes, he is hitting you. That is bill. The denominators are, they are capacity, resistance, or the money in the pocket. How much, if someone hits you, how much you can retaliate. See this way, your capacity. See, you fold the shirt this way, you are hitting me, come, I am ready. See, when you are ready for receiving, that is equivalent to denominator. Someone will tell, alpha is there, keep quiet, I will tell him. I am telling them the logic, don't talk too much. Then I will ask him, do you know how this came? No, keep quiet. I know how it came. I know how it came. Even that alpha n depends on PU by PUZ. I know the reason and I can almost prove it. Exact, not possible, because empirical. Then you don't comment that way. I am making public easy understandable. Don't worry about alpha n. Numerator is hitting. Denominator is, numerator is hitting or bill. Denominator is your capacity or how much money you have got. Tell me, do you want action more or resisting capacity more? Do you want bill more or money more? Tell the answer. Do you want bill to come more or money in the pocket more? Tell the answer. Which one you want more? You want bill to be more or money in the pocket to be more? What do you want? Your batch, it was not there because I stopped. After doing first batch, no problem. I saw the message, no problem. After the first batch, they only told me, Kannadadalli, sir, idi yaarigu madbedi sir, innu 15 classes over, and that much I can't afford. There's a limit. Then I stopped it. Remaining around 7-8 batches I had taken professional training. I have not done it. I told equation. I told the reason. Logic I told. Proof all I have not done. Because you always want money in your pocket more, or see, numerator is equivalent to hitting. Denominator is equivalent to resistance. So you want resistance more. That's why the ratio should be always what? Tell me. Tell me. You want numerator more or denominator more? Tell the answer. Do you want numerator more or denominator more? Common sense. Do you want numerator more or denominator more? Common sense. You want denominator more. So that's why ratio should not come. What? When the denominator is more, ratio should not come. What? Ratio should not come. Ratio should not come. Answer. It should not come. Little fast. More than 1. Correct. Or remember, now some note you have to write. This money matter I will remove. See, MU1 is known, MU2 is known. I won't write here. Tick mark is here. MU1 illide ನೋಡಿ. MU1 is here. illide. MU2 double right. illide ನೋಡಿ. MU2 double right. I won't tell every time. So the numerator is known. Now you want denominator. So and now I'll tell you. And MU, my symbol, MU01 and MU0. Not means our IS code used the word dash, I think, correctly. They used the word, no, they told 1. See, IS code used the word 1 and 2. They told one of them MUX, other is MUX1. Other they told MUY, MUY1. Their one is that not. But since you are taking 1 and 2 for the axis, I am using not. Do not bother about IS code. So IS code I told what? They used, instead of not, they used the suffix 1. Suffix 1. But 1 I can't use because 1 and 2 is axis for me. So I told not. You stick to my principle. My principle can never be wrong. Okay. MU01 and MU02 are, tell me, are they action or capacity? Tell the answer. The denominators are what? Are they hitting effect or capacity? What you can tell? What is that one? Remember that much. Is it hitting effect or capacity? Denominator. They are capacity or IS code told. See, see, they used the word. You write. I am not wasting time. Or, okay, uniaxial, that is independently. Once for axis 1, 1, once for axis 2, 2. Uniaxial, see, or maximum understood. That is maximum money you have got. Maximum uniaxial, they told moment capacity. This is one thing. IS code I will tell the IS code. You are wrong. Do not use the word moment. Tell what they should use. If IS code meeting is there, I will tell them very firmly. You please do not use the word moment. What use? Why you spoil the subject? How much printing cost comes more? I will tell them, in future, do not use the word moment. You are misleading people. Use the word what? I will tell them, openly I will tell them, you are misleading. Do not use the word moment. Use the word what? No. Not moment, what? Bending moment. See, I will tell them, how much printing cost? I will tell, I will give you money. Because of that way, IS code may need one more page. Where our moment is there, put bending moment. I will tell them, respect to subject is not there. Okay, leave it. Uniaxial, but I will write uniaxial bending moment, of course, factored bending moment, what? Use the word there, moment, capacity, bending moment capacity, bending moment capacity. Remember, capacity means how much can be resisted, how much maximum can be resisted. Okay, this is also over. Okay, now little furthermore, see, I may remove this one now. I will do one thing now. I will substitute now only, so that later no problem. MU1 110 to the space there. Okay, leave it. Anyway, that much you can make out is here. This I will not remove. Okay, done. Capacity means how much it can resist. Over. Now, what you require is alpha n. Alpha n is a factor. This I cannot talk because beyond the scope of the subject. If I talk about alpha n, I will tell so many things about neutral axis position, how the axial load effect, how the neutral axis will come, and then how direct load and BM combination affect the variation all. Sorry, this is not a theory subject. Very sorry. You believe me, it is given in IS code. Alpha n to be obtained from table number. I will tell table number. See IS code. IS code. Table number. Table number. Ayyo. Where is the table number? Alpha n. Hey, alpha n, where are you? No, not table number. Ayyo, leave it. Actually, to be obtained as follows. As follows. That is alpha n. It is given there only. See, for PU by PU as follows, based on the ratio PU by PUZ. Based on the ratio PU by PUZ. Now, very carefully observe. PU is the action. How much is the actual load? Tell the answer. PU first. Everywhere, numerators are action. Denominators are capacity. Tell the action. PU. Answer. PU. Lag, if I remove, lot of plants are, and if I am able to remove the lag, I can stop the class suddenly and tell the contesting. I can show angriness. You don't answer, I am stopping the class. I can tell. But because of lag, I am helpless. It is not justice because you are hearing it late. Answer PU. Today only required 1200 10 to the power 3. That is action. PUZ, if you remember, I told you earlier, PUZ is what? Uniaxial. The correct word I want. PUZ is their word. PUZ. I told you long back, PUZ. Formula is there. You see, I know 0.45 FCK. PUZ is, they are not told what is PUZ there. Where they told? Somewhere they told. PUZ is, actually, PUZ means axial load carrying capacity. Carrying capacity for a short column without considering eccentricity. That is, your PUZ is, remember, if you consider minimum eccentricity, PU is 0.4. But if you don't consider eccentricity already considered there, then PU, I told in RCC batch very clearly, my purpose is for RCC batch. Whereas ETAP batch also I told, for PUZ, number is not 0.4. Tell the number. See the IS code there. For PUZ, number is not 0.4. What is the number? For PUZ, see, PU formula is 0.4 FCK into AC plus 0.67 FY into ASC. But for PUZ, number is not 0.4, 0.45 FCK into AC plus 0.75 FY into ASC. Remember, this is a formula for PUZ. Anyway, nothing to worry. It is given in the IS code, page number, same page number. Which page number? Same page number, 71, it is given. In page 71, they are given it. Page 71, they are given. Now see, ASC here, ASC is, remember, ASC is cross-sectional area of steel. And AC is cross-sectional area of concrete. Remember, AC is always equal to gross area minus area of steel. Gross area minus area of steel. Our question, tell the gross area first. Our question, tell the gross area. Column is of cross section 300 by 600. Answer. Gross area is 300 by 600. Correct? This is the gross area for our cross section. Then, therefore, AC, therefore, your AC equal to 300 by 600 minus area of steel. ASC. And now remember one small point. I will write this side now. Their space is not there. I will write here. Okay. These all I can remove. Oh, these all I can remove. Remember, FCK is 25 tomorrow or later. Remember it. Not today, little later. FCK is 25. I am removing everything now. I will make a note somewhere here if I require. PU 1200. I will forget later. MU1 is 100. MU2 is 116.08. Cross section I remember 300 by 600. You can't see it. Why? My reference. And M25 concrete, FE 500 steel, chart number 47 to 50, and then D dash equal to 52.5, and that's all. Yes, that's the answer. Okay. And gross area equal to, I'll write later. Gross area is 300. Now ASC required. There, and remember now, I will remove everything now. Good catch. See, this full I am removing. Now onwards, remember, when I continue, if I ask axial load, tell 1200 kilonewton, conversion I will do it. If I ask you this factored BM, about 22, tell what? 116.08. If I ask you this factored BM, 100, that is about 100 kilonewton meter. And if I ask you FCK, remember 25, I can't tell every time. FY 500 and D dash 52.5. Chart number 47 for D dash by D 0.05, 48 for 0.1, 49 for 0.15, 50 for 0.2. Show me a person who will tell this much again and again. Let me see. A person who will tell this much again and again, again and again. Once they tell only is more sufficient. Okay, now little I remove and start now. See. At least I want to do one trial today. No problem. Little time it will take also. One trial today. Yes or no? If you are agreeing, at least one trial today. You should wait for little more time. From 9:30, it may take a little more time. Correctly, what all we covered, so that if I continue tomorrow, those who are absent today, I can take care. I can tell, don't come to my class. See, when I do revision tomorrow, not much. Tomorrow I need only 1 hour. I think I need only 1 hour today. So tomorrow 1 hour I need for column, because I am not hurrying. I should tell you about that Excel sheet also. So, or I will ask someone to prepare Excel sheet today. I will ask him to watch the class. I will dictate him. Okay. Therefore, little 10-15 minutes more, no problem. Tell me, if 10-15 minutes is no problem, I will finish one trial today, so that actually purpose will be over. No answer. Around 10-15 minutes more, so that one trial will be over. Okay, no problem. Start. Now, remember now, therefore, your area of concrete, remember now, area of steel is always equal to what? ASC equal to, see there, you know that percentage equal to 100 into AS. AS or ASC both are same. I use the word ASC. Actually, AS is correct. Don't use ASC now. Instead of ASC, you use the word AS, because when you do compression, it is ASC. When you do full column, it is AS. Both are same. So, percentage is 100 AS by gross area. Therefore, your area of steel equal to what? Percentage into gross area, or it is percentage by 100 into gross area, or equal to percentage by 100 into 300 into 600 is the area of steel. And area of concrete equal to 300 by 600 gross area minus area of steel. This over. Start. Now, first step is what? To assume steel. How much steel you have to assume, I can't tell right now. See, you should assume steel, minimum steel is 0.8%. Maximum limit is 6%. You do not know how much steel required. You tell me 1% randomly. It is called trial and error procedure. You try a percent. If it becomes unnecessary waste, reduce the percent. If it becomes unsafe, increase the, right here. Percentage of steel to be assumed. I already told you. Percentage of steel to be assumed. Where I wrote it? Somewhere I wrote. I don't know where I wrote it. See, suitable percentage. You assume a percentage not less than 0.8, not more than 6%. Then, see, same thing ETAB also is doing. It will keep on doing trial. It may start from 0.8. Okay, now, once you assume a percentage, check the safety. If it is very, suppose you find ratio instead of 1, you get 0.3, 0.4, means waste. See, that means over strength. If it is highly over safe, uneconomical, reduce the steel. Or if it is unsafe, increase the steel. Tell me, a design is the best design or the most, if you can make the ratio, exact one not possible. So a design will be very economical and also safe if you make the ratio, how much, tell me? Very nearly equal to. If you make the ratio very nearly equal to how much? If you can make the ratio very nearly equal to how much? Very nearly equal to. So no wastage. A design is a very economical design and also safe design if you can make the ratio very nearly equal to. Very nearly equal to. Why 0.8? Best design. Very nearly equal to. Very nearly equal to. Not 0.8. 1. But slightly less than 1 or more than 1. Slightly less than 1 or more than 1. Correct. 1 is not possible. You should not exceed 1. Slightly what? Less than 1. Say 0.98, 0.99 is the best design. But practically what people will do is, they will not go to 0.99, 0.88, 98. They have got a fear. So what people will tell is, in the design office they will tell, don't go to 1. The IS code will tell you, for safety do one thing, have little more money in the pocket. So practically people are happy if the ratio comes around. Tell me how much? Yes, somebody sold the answer. That's good answer. Little reserve strength required. They want little reserve strength. They do not want to reach the critical state. So people will tell good design with a good margin of safety, not 1. Tell me one answer told someone. Correct? How much? Around 0.8. If it is around 0.8, 20% reserve strength. That way you decide. Anyway, that is your personal. IS code told should not exceed 1. Start. Now, let us initially assume percentage of steel, that is called P. That is your trial 1. I will take trial 1. This one is not axis 1. This one is not axis 1. This is trial 1. Trial 1. Oh, one thing forgotten. Okay. I will tell you. Trial 1, say, tell some percent. Anything you tell, I will take. Not less than 0.8, not more than 6. Randomly tell the answer. Same thing ETAB is doing. It will keep on changing percentage. See, for this one, if Excel sheet is there, it is very good. So tomorrow, I will tell you how to prepare Excel sheet also. Answer. Tell some percent. Some answer tell me. Randomly, whatever you want. Okay. 2.5, Nanda Kumar told. Okay. 2.5%. See now, suppose somebody will ask me, sir, why 2.5? Then tell something. If you do not want 2.5, tell something. See, then tell something. You keep quiet. So 2.5. Tell the answer. Therefore, your 2.5% means one small problem. 2.5 by 25 is exactly 0.1. Correct? See, sorry, Nanda Kumar. If you take 2.5%, 2.5 by FCK will come 0.1. If it is 0.1, it is easy for you to see in the interaction diagram, 0.1 curve is there. I want difficulty. So I will take, sorry, I am superseding you. I will take 2%. No hard feeling? Tell me. 2.5 means when you take P by FCK, it will become 0.1. If it becomes 0.1, your curve becomes easier for you. In the class, it should not be easy. So no hard feeling? No hard feeling? Okay, 2%. Okay. Now, therefore, your area of steel equal to, see here, 2% by 100 of 300 by 600. Tell fast answer what is area of steel in mm square. Answer fast. Fast answer. Based on 2% steel, what is the area of steel? Answer. Based on 2%, what is area of steel? I have got a calculator here. Deliberately, I am not using calculator. If you want to learn at least that much contribution, if you want to learn 36, ayoyo sahebre, you are giving shock to me. 36,000 mm square means, see, I am Kannadalli, ನೀವು ಅಂದ್ಕೊಂಡಷ್ಟು ಪೆದ್ದ ಅಲ್ಲ ನಾನು ನೋಡಿ 36,000. You require 75 bars of 25 torque. See, I am not that much weak in subject. 3600. It is like telling, see, 3600 mm square. I will go to a coffee shop. How much coffee? He will tell, sir, 36 rupees including tax. ಸ್ವಲ್ಪ ಕಾಸ್ಟ್ಲಿ. ಓಕೆ. He will tell, sir, 360 rupees. No, I know 360. Darshi, good hotel, not 5-star hotel. A good hotel. He tells 36 rupees. Agreed. 360 rupees. I will not agree. Okay. Therefore, tell me what is area of concrete. First, 300 by 600 minus 3600 is area of concrete. I forgot one thing. I will tell you. Area of concrete. Answer. Why? I want, see, substitute here, PUZ. As soon as I change the value of percentage, first I will come to PUZ. Why? Reason is there. I first want PUZ. Then I will go to the chart. PUZ. 176400. 176400 mm square is AC. Substituting, see, some will tell, why you are doing PUZ first? You can do this alpha, M01. Wait, you are, see, we require MU01, MU02, alpha N, you require PU and PUZ. Any order will do. I prefer, some order I like. You interchange. When you go to a function, they put so many items there. Which one to eat first? Anything you eat first, no restriction. But when they serve later, then there is an order is there. See, they serve what? Some order. They don't put curds in the beginning. No one will give in the beginning curds. In the beginning ice cream. No, ice cream last. That way. But when they put initially something in the leaf, that plate, you can eat it anything first. No restriction. Why you took that palya first? Why not kosambari first? Means, hey, sumne kutkala anta. Okay. Yes. See. Substituting. Tell me what is PUZ. Any PUZ? 0.45 into FCK is 25. Area of concrete 176400 plus, I will put down here. Okay, plus 0.75 FY is 500 into area of steel is 3600. This will tell you PUZ in 10 to the power 3 Newton. Answer fast. PUZ is a force. It will give you 10 to the power 3. One thing I forgotten. How to get PUZ alpha N, I am not told. I will tell you now. So, and also one more thing forgotten. Deciding breadth and depth. No problem. I will explain everything today. Answer. PUZ 176400 or ಎರಡೇ ಸೊನ್ನೆನಾ ಇನ್ನೊಂದು ಸೊನ್ನೆ ಜೋಬಲ್ ಹಾಕೊಂಡ್ರಾ ಸಿ 17640 3334.5 ಗುಡ್ 3334.5 10 to the power 3 Newton. Correct answer? Okay. PUZ. Now our purpose is to find alpha n. I forgot. See, alpha n. So to get alpha n, you find PU by PUZ. I already told you. PU is long back over. How much PU? 1200 10 to the power 3 divided by 3334.5 10 to the power 3. It's a ratio. There is no unit for that one. Tell the answer. PU by PUZ. Answer. PU by PUZ. Point. Little fast. Point. PU by PUZ. Point. Oh, this much difficulty. One answer. The lag should be 0.3598. Okay. 0.36 I will tell. Or 0.3598 is 360. I want third decimal. Sufficient. I want third decimal. 0.35. How much answer? 0.35. You told. Don't give wrong values. Suppose anything is wrong, others should not comment later. I will tell you why you are not told. 0.3, only 1% participating. Others, they are there, still not there. This is very bad. If you don't participate, how I know that who are there? I have no idea who are participating. At least involvement required. That's why tomorrow, see, I'll stop the column. As soon as column is over, I'll suddenly change the app and go to Zoom and continue the class foundation for my regular students. Newcomers, public, I'm stopping tomorrow. That's the reason. See, it is not that I want more people. That reason is there. If there is nobody to respond, there is no, what you call, satisfaction will not be there. Okay, you pay for it. 0.360. Okay, now, do one thing now. This I will remove. Now, I forgot to tell you how to find PUZ. I'll write here. See, this space I don't require now because why? Already over. The ratio also I'll remove. Why? You know it already. This all I can remove. Y means already over. See, already over. Therefore, no point in wasting time for those which are already there. Okay. Now, start. Once you get which one? PU by PUZ, refer to IS code. Okay. Refer to IS code. Now, refer to IS code. IS code told very clearly, see, they told if for PU by PUZ, remember, PU by PUZ is a what? It is a non-dimensional parameter. Why? Ratio for PU by PZ, PUZ either less than or equal to 0.2, they told alpha n directly. Tell the answer. See there. For little, they are not given correctly. I will tell you. They told if PU by PUZ is less than 0.2, they told alpha n equal to. Answer. That is, PU by PUZ is less than 0.2 means axial load very lesser, whereas bending is predominant. Then they told alpha n equal to how much? For PU by PUZ less than 0.2, they told alpha n. See IS code first. They told alpha n equal to. See the answer. See IS code and tell me. 1. Alpha n is 1. 1. And for PU by PUZ more than 0.2 but less than 0.8, alpha n varies from 1 to how much? For more than 0.2, less than 0.8, alpha n varies from 1 to. Answer. 1 to 2. 1 to 2. That means PU by PUZ equal to 0.2, alpha n equal to 1, and PU by PUZ equal to 0.8, alpha n equal to 2. A table. Okay, now. And also for PU by PUZ more than 0.8, they told directly alpha n equal to how much? Answer? Tell me. They told alpha n equal to. If it is more than 0.8, alpha n equal to. Answer. That is 2. Alpha n equal to 2. Here you go for linear interpolation. interpolation. Remember, in my YouTube channel, Mathematical Tricks class number 3, I completely grinded linear interpolation. Okay, now, I will not tell once again in this class, if you get PU by PUZ less than 0.2 or even equal to 0.2, then keep quiet. Keep quiet. Means what? Directly take alpha n equal to 1. Thank you. Also, if your PU by PUZ comes more than 0.8, that is, load is very predominant. Load is very predominant. Then they take alpha n equal to 2. But if your PU by PUZ comes in between 0.2 and 0.8, in between 0.2 and 0.8, then you interpolate from 1 to 2. Fully clear or not? Tell me. Fully clear or not? First, I will not explain once again this one now. This is permanent now. Take a screenshot. This is permanent. Take a screenshot. Any problem? There is some, I am seeing some problem there. Is it clear? No, that is net problem in the mobile. No problem. I am seeing some that route circling that is in this mobile. No problem. Okay. Not there. Everything clear. Clear. Okay, now. So our case, usually remember, now you should not talk. If you get less than 0.2, silently keep quiet, take 1. If you get more than 0.8, take 2. If you get in between, go for interpolation. So, therefore, for our case, what? Tell me. That is, your PU by PUZ equal to, how much answer? 0.360. Go for what? Tell me. For our case, go for what? Go for our case, go for our case, go for what? Network connection. Then retry. Okay. Some problem there. Okay, I think 1 minute. I will put Wi-Fi on. Okay. My data is over. That's why. Okay. Data is over. In this mobile now, Wi-Fi is on. Now okay. Correct. Data problem. You have to go for linear interpolation. Linear interpolation. Therefore, tell the answer. Therefore, for our problem, our present case for PU by PUZ equal to how much? 360. Anybody can tell me what is alpha n? Remember, I should write alpha n also. I'll forget later. How much trial 1 is 2% steel, alpha n came. Answer. Alpha n. I will note down there. Answer passed. Interpolation. Answer passed. 1.267. 1.267. Thank you. 1.267. Okay, now too much time is there. When I ask you in the continuation what is alpha n, you have tell 1.267. And later in the subsequent trials, if I get different PU, when I change the steel, area of steel will change, area of concrete will change, PU will not change, PUZ will change, ratio will change. Then alpha n, without my explanation, can you give or not? Tell the answer. Now onwards, in my class, for this question, in the subsequent trials, when you redesign is there. When we redesign, alpha n value, will you tell or not to me? Will you be able to tell or not? Now onwards. Means absolutely should be clear. Now you should tell alpha n is no problem for us. Alpha n is no problem for us. Yes or no? First. You will agree now. I cannot explain again and again like this in the subsequent trial. I cannot keep on telling this way. See, PU is so much. Yes, you agreed. And remember, already 9:45. Okay, I will continue. Little more is there. Okay, enough. Because already time over now. Leave it. I will continue tomorrow. Tomorrow I may require 1 hour for this one. That's all. So tomorrow 1 hour, everybody can come, no problem. All can come tomorrow. And tomorrow I will do one thing. For the RCC group and ETAB group, I will send one more link for you. Remember, one more link for you, that is Zoom link. As soon as I finish columns here, when I complete columns, I will tell goodbye to everybody. I will tell column and foundation I committed, but because of your not showing interest, I have decided not to continue foundation. You are going to miss, but not you. So immediately I will switch off I will end the live stream, and then I will change to Zoom using the link sent to you. Those who are in the ETAB group and also in what? RCC group, join immediately to my Zoom class. Clear? When I finish the column tomorrow, I will tell you column part is over. I am telling goodbye, little premature. Why? Because of no cooperation. I will tell further I am not interested in continuing. Yesterday when I told you in BSK class, not interested. When people does not deserve it, I don't want to continue. Okay. For me, no problem. It is not a big issue for me. So, clear? The moment I finish the column, I will tell goodbye. For everybody, I will wish all the best. Why? General public will be there. Then some will tell, sir, continue foundation. No, not continuing. I will tell you don't deserve it. But then, don't leave the class. Immediately using the link sent to you, log on to Zoom, and I will start foundation tomorrow. Very critical part for RCC. The most important. Those who are in the group, clear now? Okay. So tomorrow I will continue now. Thank you for all who watch in the class.